Hello, and welcome back. This video is about placing and rotating tiles. And a special thanks to all my supporters. Thank you for helping me help others. When working on the prep project for this video, I realized I missed a few things. Namely, the build helper save game will save the tile type, but we also need to save the rotation. Similarly, in our build level blueprint, the added tiles map saves the actor created so that we can destroy it as needed, but we can't easily get the tiles type from it. We can resolve both of these issues by converting the value in each of these maps to a struct that holds more data. And to save a little time, I added these before launching the editor. So we have a build helper data, which just adds a rotation around Z, and we're using an int for this so that there's no floating point drift. And for the added tile, we had the tile actor. We're also adding the tile type and the rotation around Z as well. So that means we have to update a few things. So we'll start with the editor utility widget. So in our apply button here, we're loading the game from the slot, we're converting it, and then we're getting the tiles from it. So if we convert this here, the int vector from a tile type to our build helper data. And then in here, if I just hit compile, you'll see there's errors. So now we want to get the tiles again. Actually, I guess it did update this part, but the call to build tiles need to be updated. So for build tiles, we're changing the tile type again to build helper data. It's fine here, but obviously in the function, we then want to redo a little bit of this. We'll get our keys, we'll call for each on it. We have to update our tiles here. So instead, we'll get tiles again, the parameter sent in, use that to call find, sending along this value here. And now we have the data structure to get the enum, then we need to break that. And to use this rotation around Z, we can split this rotation pin. And drag it into the Z component. And the rest here should be fine. In our build helper level, similarly, we have our added tiles. We're going to change this actor to an added tiles data or tile data. Now we're using this in a number of locations, so let's update that first. In our clear level, if we try to compile, we'll see some of the errors, but basically here we just need to get our values again, so we can do a for each on that. And then similarly, this is now a struct, so we have to break it. This clear is, looks like it was updated properly. Yeah, that's good. So we'll lock that back up. And then just drag the actor into here, and that's all updated as well. In load level, the tiles here has been updated, but again, we have to get the keys, do a for each on it. Do a find on the new version. break that. We also want to add the rotation around Z to the add tile function, so we'll do that here. This function should be good now. And then in add tile, back at the beginning, we want to do the same where we take our rotation here, we split it. We can drag the Z into the Z or Z if you prefer. Over here, I'm going to drag this out a bit. I'll explain why shortly. And we have to get rid of this add, re-add it. And now we have a struct, so in this case we can call make. That will be the tile actor here. And the two values sent in, get tile type and get rotation. And this function is fine now. Okay. All right, so now we'll add a new function. The opposite of add tile will be delete tile. In here, we're going to get our added tiles array. We're going to find using the location that is sent in. Location is an int vector as a reminder. As long as that is found. We can break this to call destroy actor on the actor. And then copy this over here so we can call remove based on the key that was sent in. Now this does mean that we go in here and we hit play. It calls the load level, sends along the build helper slot, but it doesn't create any static meshes because the build helper save file is now in a different format. So it basically just fails to get the tiles from it. And we'll fix that in the next video, but for now we want to add a little bit more functionality. So back in our begin play, we're now going to spawn an actor. This will be a static mesh. Well, static mesh actor. Split open the spawn transform so that it doesn't complain. We're going to save this as select actor. And I'll leave that for now to show the issue I alluded to in the other bit. This means we also want to update our on tile selected. So in on tile selected, we're going to get our tile meshes. We're going to call find. We're going to accidentally do that and then call find. This will be the tile type here. I want to make sure that it's valid. Oops. And then we're taking our select actor and we're setting the static mesh on that. To the value found in tile meshes. Now back in our event graph, we go down to our tick event. I'm going to add a new function called update select actor and make sure it gets called on tick. And what we're doing here, we've seen variations of this a number of times. Basically, we're going to get our player controller, and instead of calling the get hit result under cursor, either of these, so what this function is doing is it's calling get mouse position, and it's using that value to send to deproject screen to world, which gives a world position and direction for the mouse cursor, effectively. Now we can also call those functions here, but there's also a shortcut. Those functions are also called by convert mouse location to world space. So similarly, this will just call the get mouse position and the deproject and give us our world location and direction. So in this case, we want to use this information, and we're going to be calling line plane intersection, and we want the origin and normal version. The origin is fine, that's just the center of the world, and the normal we'll just set as up. So 0, 0, 1 is just up. For the line end, we want to take our world location, we add a value based on the world direction, and we're just putting a sufficiently large number here. This number effectively just needs to be the distance from the camera to the furthest point visible on the plane at 0, 0 and facing up. So 5,000 is more than enough. So if we use this information to get our select actor and set its actor location, we can send that in directly here. There's going to be a little bit more to that in a sec. But if we run this as is and we select a tile type, you can see nothing happening. That's because of all of this. So basically what this is saying here is our static mesh actor. It has a static mesh component. It has to be movable if you'd like to move it around because it's static mesh. So that's what I was alluding to earlier. So that means back in our begin play, way over here, we want to take our actor and we want to call set mobility. This will be called on the static mesh component. And in this case, we want it movable. So with that done, we now have a tile type that updates based on the button that we click, and it's just moving, hitting where the mouse intersects with the 0 up plane. So with that working, we want to improve it a little bit. We'll go back into our update, select actor, and we want to take this intersection location. We're going to divide it by 100 because that's the size of our tiles. But first we want to add a vector of 50, 50, and then we'll divide by divide by 100. Set this to a float of 100. And then we want to split this so that we can convert X and Y, or specifically call floor, which will convert them to an int. We use floor here instead of round because we want negative values to work appropriately. And since we'll be using these values elsewhere, we also want to make a variable called select location. It's going to be an int vector, but not a map. And we can drag this out here. Oops. We can split this out and then just drag in the X and Y because we don't care about Z. And lastly, this is what goes into here now. So there's a lot going on here. We'll just go over it one more time. We're getting our player controller so that we can call a few functions inside here, which will then take the mouse position, deproject it to world space, giving us the world location and direction. We're using those values to make a line start and line end to intersect with a plane, set at 0, 0 and facing up. We're then also now moving it slightly so we can divide it by 100 so that it works like a grid. We're flooring those values, we're saving them for later, and also using them to update that location. So now when we run it, we see that I forgot to multiply it back by 100. So these values here actually need to be reset to their original values in a grid. So I'm going to multiply both of these by 100 before we set them in here. And there we go. We move between grid spots and it just pops it into the new location. So the last thing we want to do then is back in our event graph, we're going to add a few more mouse events. So first we want mouse wheel up and down. For these, we're going to take our rotation around Z, which is an int. Oh, because it's the same name as a variable used in a function, it's complaining. All right, so this one I'm just going to call ROT around Z and switch this one to an int. And hopefully it didn't change the name on the other spots. No results found, that's fine. So we'll drag these in. For the one, we want to subtract 90. And for the other, we want to add 90. We'll keep doing that. Add, then 90. And in both cases, we're just setting it here. And using that to take our select actor, set its actor rotation, splitting that out, and then dragging in our road around Z. And both of these paths can just call this function. We also want a left mouse button. You could, of course, be using input events for the enhanced input for all this instead, but we've gone through that before, so don't need to do it again, and this is a little quicker. So in here, we're calling add tile in this case, and del tile in this case. In both cases, we're taking our select location that we've saved, sending that along with the selected tile type, and the rot around Z. So now when we select something that can be turned, we have it here. If I rotate the mouse wheel, then you can see it's turning the one way or the other way. And lastly, if I click, it does nothing because something is missing. Ah yes, that was the other part. So again, we have our static mesh component complaining that the mobility is static. In this case, it's in the add tile function. The one over here, we can call our set mobility directly here on the static mesh component. And you could set this to movable like we did with the select actor that actually needs to be movable, but this one can just be stationary because we are only ever setting it and either re-adding it and or deleting it and re-adding it or not. Ah, yes. So when I did the rename, it actually, this is why it was complaining. There's a parameter sent to this function, which was the rotation around Z. So we'll have to get that again. This is why using the same parameter names in functions and globally here can be a bit of a problem. So now when we hit our corner path, we left click, place it down. There we go, and we have our straight paths. So in a future video, we'll actually save this information back to the build helper save game, and then get it working with the editor utility widget in a new level. Thanks for watching. If you liked the video and would like to see more, you know what to do. And if you would like to support this channel, watch these videos 2 weeks early, or just want to download the project files, you can do so through my Patreon linked below.